All right, so for anybody watching this video, I'm going to work straight through every single one of these problems. And I'm going to do it quickly, so I'm not going to explain much, but hopefully by the time I do 9 of this type of problem, you'll understand it. Hopefully by the time I do 14 of this type of problem, you'll understand it. Okay, so here's the idea. Well, I guess I said I'm not going to really explain much, so here we go. So the domain restriction, that comes from what you can't divide by. You can't divide by 0. So if x were 0, then you'd be dividing by 0. So that creates a problem. So x cannot equal 0. That's my domain restriction. So x cannot equal 0. Let's go ahead and do actually the first 3 all together. X cannot equal 0 on this one. If I look at that one, x cannot equal 5. If I look at this one, x cannot equal -1, and so on and so forth. I think you might get the point now, or at least be onto it. So with each of those domain restrictions, they will express themselves as either a vertical asymptote or a removable discontinuity. And the way you know which it is if it cancels with something up top. So if that x canceled with an x up top, then it would be a removable discontinuity. But because it doesn't, it's a vertical asymptote. So the vertical asymptote exists at x equals 0. As far as removable discontinuity, because nothing canceled, there are none. Horizontal asymptote, remember there's 3 situations you can have, and it has to do with the degree of the function. So if the degree on top is bigger or smaller than the degree on bottom, so you have a lower degree over a higher degree function. So low over high rhymes with y, so it's y equals 0. Okay, let's go on to number 2. Again, that's going to be either a vertical asymptote or a removable discontinuity. Question, does it cancel with anything up top? No, so it's a vertical asymptote. As far as removable discontinuity, there are none. Horizontal asymptote, small degree up top, bigger degree on bottom, so it's lower degree over a higher degree, low over high, rhymes with y, so it's just y equals 0. This one, again, let's just do it again, low over high, so that's y equals 0. Hopefully we're going to get some high over lows, and then maybe some of the same degrees, and I'll show you when we get there what that looks like. As far as, does this cancel with anything up top? No, it doesn't, so that again is a vertical asymptote. So all 3 of these were very, very, very similar. -1 is the vertical asymptote here. There are no removable discontinuities. Okay, number 4. Now, before I state my domain restrictions, it's not so easy as it was in like number 1. If you look at number 1 is can't be 0. Number 2 is your domain can't be 5. Number 3, your domain can't be -1. Okay, so on this one, you actually have to factor first. So you got x minus 3 times x plus 1 on the bottom. So if you need to factor, if you need to learn to factor, then look up one of the previous videos on that. So your domain restrictions, x cannot be 3, x cannot be -1. Guys, always start by factoring. Factor the top. 2 times x plus 2. Okay. Does anything cancel? Do any of these cancel with anything up top? No. So that means there's still none for removable discontinuities. As far as vertical asymptotes, both of them are. So x equals 3 is a vertical asymptote, and x equals -1 is a vertical asymptote. As far as the powers, the degree of the functions, well, if you just look back at the original, what you had, we had 2x and an x squared. So it's bigger on the bottom. So we have a low over high. Again, y equals 0. All right, nice. So this one's finally same degree over same degree. But anyway, let's start with the domain restriction. Can't divide by 0, so x is not allowed to be 1. X is not allowed to be 1, so that's either going to be a vertical asymptote or removable discontinuity. I can't really factor anything up top, and that's not going to cancel, so it's still none for removable discontinuity because it didn't cancel. So it must be a vertical asymptote. As far as the horizontal asymptote, it's the same degree over the same degree. They're both first degrees. So I'm going to take the coefficients. So 3 and 1. So it's y equals 3 over 1, or just 3. All right, this one. Factor everything again. X minus 3 on top times x plus 2. Okay, so there's the top factored. This time, x cannot be 3 because 3 minus 3 would be 0. So x, we're keeping x from being 3. does it cancel with anything up top? Yes, it does. X minus 3 and x minus 3 cancel. So then x equals 3 is a removable discontinuity. Vertical asymptote, you don't have any. None. So notice the difference between this one. It canceled because so now it's a vertical removable discontinuity because there was nothing left on the bottom. You didn't have any vertical asymptotes. Horizontal asymptotes, well, again, you're just kind of looking at the degree of the function. So the degree on the function on top was x squared, and the degree of the expression on bottom was just to the first power. So it's a higher degree over a low. So high over low, no. Or there are none as far as horizontal asymptotes are concerned. Okay, so next one, factor everything. 3 times x plus 3. All right, so domain restrictions. We're going to keep x from being negative 3 because negative 3 plus 3 is 0. So x cannot be negative 3. It does cancel with something up top, so it's a removable discontinuity at negative 3. I'm left with nothing on bottom after everything's canceled, so I don't have any vertical asymptotes. As far as my horizontal asymptote, it's first degree over first degree, so I'm looking at the coefficients. They're the same. So it's 3 over 1. 3 over 1. Okay, this one, factor everything. So I've got x minus 5 times x plus 1. That's that factored on the bottom. X minus 3 times x plus 1. That's that factored. Okay, so the domain restrictions, x cannot equal 3, x cannot equal negative 1. Does anything cancel? Yes, the x plus 1 cancels with this x plus 1. So I have one removable discontinuity. One of those domain restrictions, this one specifically, is a removable discontinuity. The other one that's left behind that did not cancel is a vertical asymptote. Okay, and then as far as horizontal asymptote is concerned, I have a degree 2 over a degree 2. So it's same over same. And if it's the same, looking for the coefficients, 1 over 1. Or just 1 if you wanted to write it that way. Okay, last one, factor everything. Okay, everything's factored. Domain restrictions, x cannot be 3 because 3 minus 3 would be 0. So is that a vertical asymptote or a removable discontinuity? So does anything cancel? No, nothing cancels. So it's not a removable discontinuity, it's a vertical asymptote. X equals 3. As far as the horizontal asymptote, I have a first degree over a first degree, so I'm looking at the coefficients because they're the same degrees. So 5 over 1. Okay, so that's all 9 of those. All right, next side. Multiplying and dividing fractions, it starts off with, remember, if you multiply a fraction, you just multiply straight across. If you're dividing a fraction, like this one right here, then you just flip this, so it's x plus 4 over x plus 8. Those are done. And it becomes a multiplication problem, and you multiply fractions straight across. So it's still pretty easy. With something like this, both adding, subtracting, multiplying, and dividing, factor everything first. So x minus 2, x plus 2. Again, I'm going to work all 14 of these back to back really quick, and hopefully by the time we're done, you'll understand what's going on. So that's factored. Nothing else is factorable. Okay. Next thing you have to consider is we need, well, let's go ahead and cancel things out because it's just one big fraction now. So really it's just 2 times x minus 2 times x plus 2, and it's x minus 2 times 4. So we're going to just start canceling things out because it's multiplication and division. This is what makes it so simple. 2 divided by 4, those kind of reduce a little bit to be 1/2 on the bottom. All right, so your final answer is just x plus 2 on top and 2 on the bottom. Okay, this one. Factor everything. So x plus 4, x plus 3. Okay, so that's gone. We've got x plus 4, so it's multiplying straight across, so we're just simplifying now. X plus 4 cancels with x plus 4. 4 divided by 12 can be simplified to 1/3. So my final answer is going to be x plus 3 over 3. All right, this one, division. So I'm going to first flip this right here, x plus 5 over x plus 1, and I'm going to make it a multiplication problem. So it's multiplication, So again, I'm going to factor everything. X plus 3, x plus 1, so that's factored now. Nothing else is factorable. X plus 1 will cancel with x plus 1. I have x plus 3 and x plus 5 up top. I have a 5x, so I cannot reduce any of that. So my final answer is going to be x plus 3, x plus 5, divided by 5x. Okay, that's my final answer. Next one. I've already flipped this. It was division, so I flipped it. Factor everything out, so x minus 8, x plus 8, difference of squares. Difference of squares again down here, x minus 4, x plus 4. Okay, so cancel things out. X plus 4 with x plus 4, x plus 8 with x plus 8. I end with x minus 8 up top and x minus 4 on the bottom. All right, so this one, factor everything. X plus 6. This one, can't factor that. Sum of squares, can't factor. Okay, x squared, x plus 6. This one's actually can be a little bit tricky. I could see how this one would trick some people. X plus 6 would cancel with x plus 6. I'm left with x times x squared plus 6 on top. X times x squared plus 6 on top. And I'm left with 6 and an x squared on bottom. 6x squared. Okay. All right, this one. Pull out 2, x minus 2, x plus 2, oh my gosh, x minus 2 up top. Okay, so there's that factored. That one's factored. Now I'm just canceling things out again. So x minus 2 cancels with x minus 2. 2 cancels with 2. X plus 2 cancels with x plus 2. So everything just canceled out, which means that I'm just dividing something by itself. So it's just 1 over 1 or just 1. Okay, so that's all the multiplying and dividing. Now adding and subtracting. Before you can add and subtract fractions, you have to make sure there's a common denominator. Again, you've got to factor. So this is m plus 2, m minus 2. That's that factored. This one is 3 times m plus 2. That's that factored. Okay, so now the question is, as far as these denominators are concerned, what is this side missing that that side actually has? So it's missing a 3 over 3. So I need to multiply by 3 over 3. And what is this side missing that this side had? So it's missing that m minus 2. So I'm going to multiply by m minus 2 over m minus 2. And I'm going to start simplifying this, or actually multiplying it all together. So m plus 2, m minus 2, and I'm going to do 3 times m for the left side. On the right side, I have a positive 2 times m, so plus 2m, and I have a 2 times negative 2, which is negative 4. So I end up getting a total of 5m's minus 4 over my common denominator of 3 times m plus 2, m minus 2. Okay, so next one, m minus 5, m plus 4. Okay, so that's that factored. What this side is missing that side had is the m minus 5. Okay, so now that my common denominator is going to be the same, it's going to be m minus 5 times m plus 4. I'm going to have m still on the left side. Minus 2 times m is negative 2m. Minus 2 times negative 5 is plus 10. So I end up with negative m plus 10 over m minus 5 times m plus 4. Oh, so there's that. All right, next one. Factor everything. X plus 4, x minus 3. Okay, so this side is missing the x plus 4, so I'm going to do x plus 4 over x plus 4. So notice the difference between adding and subtracting and multiplying. Multiplying is easy because you just multiply straight across. You don't need a common denominator. All this stuff is because we're trying to get a common denominator. Okay, now that common denominator is going to be x plus 4, x minus 3 on the bottom. I have x on the left side. We didn't do anything to it. I have on the right side 4 times x, which is 4x. and I have 4 times 4, which is 16. For the sake of just getting through this paper, I'm not going to simplify that, so your final answer is 5x plus 16 over that denominator. Okay, this one. X minus 7, x plus 4. That's that factored. This one is 2 times x minus 7. That's that factored. Okay, what is this side missing that side has? 2 over 2. What is this side missing that this side has? X plus 4 over x plus 4. So my common denominator now is going to be 2 times x minus 7. Both of them are going to have this as a denominator. My numerator is 2 times 5, which is 10, plus 7 times x, which is 7x, plus 7 times 4, which is plus 28. So it's going to be 38 plus 7x divided by that denominator. All right, so this one, x plus 5 over x plus 5, x minus 2 over x minus 2. There was nothing to factor. So my denominator is going to be x plus 5 times x minus 2. I'm sorry, I'm using x's. I don't think it really matters that much. You still get the point. 3 times x is 3x. 3 times 5 is 15. Negative 2 times x is negative 2x. Negative 2 times negative 2 is plus 4. So combine all my like terms. I've got 3x minus 2x, which is just x. 15 plus 4 is plus 19 over that denominator. Okay, this one. So this I can factor a little bit. 3 times c minus 4. So this side is missing the 3. So I need to multiply by 3 over 3. Common denominator is going to be 3 times c minus 4. Up top I've got 5. Negative 4 times 3 is minus 12. So negative 7 over 3 times c minus 4 is the final answer. Okay, this one. 3 times x minus 8. This one is x plus 12 times x minus 10. All right, so this side is missing x. Is that right? Yep, x minus 10 over x minus 10. This side's missing. Whoa. What did I mess up on? This should have been an 8, which means this is a plus 10. All right, my mistake. That would have been a negative 8. That would have been a positive 10. That means this is plus 10, plus 10. This is 3 over 3. Okay, so again, big denominator. 3 times x minus 8 times x plus 10. This is going to be the last one I have time to work. So x, 1 times x, 1 times 10, plus x times 3 is 3x. Negative 5 times 3 is minus 15. So it's going to end up being x plus 3x is 4x minus 5 over that big long denominator, 8x plus 10. And I guess I'm going to leave the last one for you to try on your own. Hopefully that helped.